Welcome to tonight's video on Unit 2, Part 2. We're going to be talking about infinite series and what that means. And so as it says here in the last section, let me scroll over a little bit, a little too far. In the last section, we learned that an infinite sequence converges if and only if the limit as n approaches infinity of that sequence is equal to a real number. Otherwise, the sequence is divergent. Similarly, we can say that an infinite series of a sequence, a sub n, converges if and only if the sum of that sequence is equal to a real number as well. Otherwise, the series is what we call divergent. So if we talk about an arithmetic series, we talked about it in the previous unit that if it's an infinite sum, that for an arithmetic sequence, it's infinite if the difference is greater than 0. It's infinite if the first term is greater than 0 and the difference is 0. It's 0 if the first term is 0 and the difference is 0. It's negative infinity if the first term is less than 0 and the difference is 0. And it's negative infinity if the difference is less than 0. So the only convergent situation is when the first term is equal to 0 and the difference is 0. That is the only time an arithmetic series is convergent. Otherwise, it is divergent. So if we talk about geometric series, so recall the sum formula here for a finite geometric series. And remember in the last unit we just defined that if r is a real number, the limit of r to the n as n approaches infinity is infinite, does not exist if r is greater than 1, meaning it just keeps going up and up. Does not exist if r is less than or equal to -1, because that means it oscillates back and forth. It's 1 if r equals 1, and it's 0 if the absolute value of r is less than 1, meaning it's between -1 and 1. So like 1/2 or -1/2. So what about the sum, the infinite sum of a geometric series? So if you remember an infinite sum here, derivation of the infinite sum here. So if you notice, the limit as n approaches infinity of the sum, so notice the sum has two parts. It's the first term times r sub n, or sorry, r to the n minus 1 over r minus 1. So if you break that up into the limit of the first term over r minus 1 times the limit as n approaches infinity of r to the nth minus 1. Well, this here is a constant, right? It's just a constant, so it's going to equal a sub 1 times r minus 1 times the limit of r to the nth minus the limit of 1. So then it's the first term over 1, r, the ratio minus 1, times the limit as n approaches infinity of r to the nth minus 1, because this is equal to 1. So now, because depending upon what the answer to the limit as n approaches infinity of r sub n of r to the nth is, there's multiple answers. So for case number 1, where r is greater than 1, basically there's 3 situations, right? If we look up here, if r is greater than 1, it's going to be infinite and does not exist if the first term is greater than 0. It's negative infinity, or does not exist, if the first term is less than 0. So it all depends on the first term there. Because if you notice, when r is greater than 1, this becomes infinite, right? So it's infinity minus 1, which is infinite. So basically, if the first term is positive, then that means that this is going to be infinite or does not exist. If the first term is negative, it's going to go towards negative infinity, it doesn't exist. And if the first term is 0, then the sum here would be 0 because you have 0 times infinity. Now, case 2, if r is less than or equal to -1, the limit does not exist. So that means that you can't find this because this would oscillate back and forth, which means the limit here does not exist, which means the sum does not exist. So then case 3, if the absolute value of r is less than 1, that means that the limit here as n approaches infinity of r to the nth is 0. So 0 minus 1 is -1. So that means that when you multiply by -1, you get the formula, the first term over 1 minus the ratio. So to summarize here, the only time you can find the sum of an infinite geometric sequence or series, and the only time it's convergent, is when the ratio is less than, the absolute value of the ratio is less than 1. And that is found by the formula a, the first term, divided by 1 minus the ratio. So for example, here, number 1, it says, find the sum for a sub n equals 1/2 n minus 1. Well, so the ratio here we know is 1/2. So that fits. It's between, the absolute value is less than 1. So to find the sum, it's equal to the sum as I equals 1 to infinity of 1/2 to the I minus 1. So the first term here is 1, because if we put 1 in, 1/2 to 0 is 1. So it's 1 over 1 minus 1/2. So it's equal to 1 over 1/2, which is 2. So if you look at number 2, we're finding the sum of the infinite terms, which I equals 1 to infinity, of -2 times 1/3 to the I minus 1. All right, so the first term here, if we put 1 in here, we're going to get -2. And the ratio is 1/3. So it's equal to -2 over 1 minus 1/3. -2 over 2/3, which is equal to -2 times 3/2, which is equal to -3. All right, so number 3, the ratio is 2/3. The first term, if I put 1 in, is going to give me 10 times 2/3, which is equal to 20/3. So to find the sum, the infinite sum, if I equals 1, going towards infinity, of 10 times 2/3 to the I. So it's going to equal the first term, which is 20/3, over 1 minus the ratio. So it's 20/3 over 1/3, which is going to equal 20 when you multiply by the reciprocal. So number 4, you need to be careful because it starts with 3. So the ratio is 2/3, but the first term, 10 times 2/3 to the third, So it's 10 times 8/27. So it's going to be 80 over 27. So when you find the sum of the infinite sequence, starting with I equals 3 here to infinity, of 10 times 2/3 to the I, it's going to equal 80 over 27, that's the first term, over 1 minus the ratio. So it's equal to 80 over 27 over 1/3. Well, 80 over 27 times 3 is equal to 80/9. All right, number 5. Well, number 5, you notice that the ratio here, the absolute value of the ratio is bigger than 1. So since the absolute value of r is greater than 1, that means the sum is equal to infinity, which means it does not exist. So number 6, now the ratio is 1/7. The first term, you're going to put 4 in for I, so it's negative 49 times 1/7 to the 4th. And 1/7 to the 4th is 1 over 2,401, so it's going to be negative 49 over 2,401, which reduces to negative 1 over 49. So since the ratio, the absolute value is less than 1, the sum, the infinite sum, as I is equal to 4, going towards infinity, of negative 49 to the 1 times 1/7 to the I, is equal to the first term, which is negative 1 over 49, over 1 minus the ratio, which is 1/7. So it's equal to negative 1 over 49 over 6/7. When you divide and multiply by the reciprocal, it's equal to negative 1 over 42. All right, so the next part, we're going to use the geometric series to prove that 0.9 repeating is equal to 1. Well, remember, 0.9 repeating is equal to 0.9999 all the way. Just keeps going. So that is equal to 9/10 plus 9/100, which is 9 times 10 to the second, plus 9/1000 times 10 to the third, plus 9/10,000. All right, so then that means that the first term is equal to 9/10, but the ratio is equal to 1/10. So if you find the sum, that's 9/10 over 1 minus 1/10, which equals 9/10 over 9/10, which equals 1. So there you go. You can also use a geometric series to write 0.0458 repeating as a fraction, because that's 0.04585858 dot 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 dot. So that equals 0.04 plus 0.0058 plus 0.00058 plus, we'll do one more, 0.00000058 dot 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 plus dot dot dot. So what that means is it 0.04 plus, and then here's the point where it starts repeating. So this is the geometric sequence. That's 58 over 10,000 plus 58 over 1 million. Actually, sorry, 100,000. And then it's plus 58 over 3, 4, 5, 6, 7, 8. 1 billion. Sorry, I put the commas in the wrong place. Doot, doot. Goes, sorry, right here. So it should be 3. So there you go, 100 million. All right, so if you look, that would be 58 over 10 to the 4th, 58 over 10 to the 6th, and then 58 over 10 to the 8th, because every time you're adding 2 powers of 10. So if you look, it's 0.04, and then this is the geometric sequence part. So the first term is 58 over 10,000. And then the ratio, the ratio is 1 over 10 squared, which is 1 over 100. So minus 1 over 100. So it's 58 over 10,000 over 99 over 100. So that's 58 over 10,000 times 100 over 99. So when you multiply, you're going to get 58 over 9,900, because you can cancel 2 zeros here, 2 zeros there. So it becomes 58 over 9,900. So what you can do then is take this 4 100ths here and add it to the sum 58 9 100ths there. So basically 4 100ths plus 58 over 99 hundredths, or 9,900. So when you add it, get a common denominator, you get 396 over 9,900 plus 58 over 9,900 is equal to 454 over 90,900, which when you reduce it is 227 over 4,950. So that is writing it using geometric series as to write as a fraction. Now the other thing it says is to write algebra, or to use algebra as to write it as a fraction. So if we did that, remember one of the worksheets we used, we took the fraction, so we take that, and now to move the decimal, we have to move it 2 spots. So if we move it 2 spots, it's 100n equals 4.585858. And then if we say n is equal to the original one of 0.045858, so on. So if you subtract, you get 99n equals, well, this cancels. So it's 4, 5. So it's 4.54. And then you divide by 99. So n is equal to, and if you move the decimal point 2 spaces here, you get 454 over 9,900, which reduces to 27 over 4,950. So that is how you write it as a fraction. All right, that concludes our video for this evening. We'll pick up with actually we'll do one more and then we'll pick up number 10 on the next video. Find the value of the following series. Well, remember this is infinite. And since r is equal to negative 48 over 64, we'll reduce that and we'll get negative 3/4. So since r is negative 3/4, which means the absolute value is less than 1, that means you can find the sum of the infinite geometric series. The first term is 64. So that means the explicit formula would be 64 times negative 3/4 to the n minus 1. So if we're going to find the sum, the infinite sum, starting with I equals 1, going towards infinity, of 64 times negative 3/4 to the I minus 1, that's going to equal 64 over 1 minus negative 3/4. Minus a minus is going to be a plus, so it's 64 over 7/4. And 64 times 4/7 is going to equal 256 over 7. Final answer. All right, I hope you enjoyed the video. And next time we'll talk about finding the intervals of convergence for some series. All right, have a good evening, and I will see you in class.